Prior to understanding the methods of riser design, we need to understand something that is called modulus of riser. Now the modulus is the ratio between the volume to the surface area. So let's take example of spherical risers. In case of spherical riser, the modulus will be given by V by A is equal to 4 by 3 pi r cube, which is the volume of a sphere, or basically a spherical riser having r as the radius, divided by 4 pi r square, which is again the surface area, total surface area of a spherical surface or a spherical riser having r as the radius. This will give us r by 3 or d by 6. Similarly, for top cylindrical risers, the modulus is given by d by 6, and the same goes for side cylindrical riser as well. It is again d by 6. Now there are 4 methods of riser design, first being the Keynes method. The formula for the same is given by x is equal to a by y minus b plus c. Here x is the freezing ratio, which is given by modulus of riser divided by modulus of casting, and y is the volumetric ratio, which is given by volume of the riser by volume of the casting, and a, b, c remains as constants. This kind of methods of riser designs are very helpful in solving numericals. Next is the modulus method, which is completely a empirical method. That means this is devised by practical means. There are no theoretical backs for the same. Here the solidification time of the riser should be greater than or equal to solidification time of the casting, and the square of modulus of riser should be greater than or equal to the square of modulus of casting. And from these relationships as well as the practical means, the modulus of riser comes up to be 1.2 times of the modulus of the casting. Next we have novel research or shape factor method. Here the shape factor is given by the summation, the addition of length and width of the casting divided by the thickness of the casting. This value of shape factor is generally taken from a volumetric ratio table, which is again a empirical made table. And last but not the least, we have shrinkage volume consideration method for riser design. For this, we first consider the volume of the riser as 3 times the volume of the casting. Then we calculate the diameter and the height for the riser. After that, the solidification time for riser and the solidification time for the casting is calculated. If the solidification time for riser is greater than or equal to the solidification time of the casting, the diameter and height of the riser that was considered earlier remains correct. And if the solidification time of riser comes up to be lesser than the solidification time of the casting, you have to again calculate the dimensions of the diameter and the height of the riser, and the process continues. So this method is again an empirical one.